Here we are going to evaluate two important limit. Okay, the first limit is limit n tends to infinity nth root of n, this is equal to 1, and the second limit is limit n tends to infinity 1 plus 2 root of 2, 3 root of 3 or cube root of 3 and nth root of n by n, this is equal to 1. Actually these two are important limit of real sequence. Okay, to find two value of limit we here use two important result. Actually one important result, this is the Cauchy's first limit theorem, and Cauchy's first limit theorem says that if xn converts to L, then yn is also converts to L, where yn is given by x1 plus x2 to xn by n. Okay, and we get an important note or consequence of Cauchy's first limit theorem. If this sequence is a positive term sequence, that is here says that if xn be a sequence of positive term, also if this limit is not equal to 0, then we conclude that x1 into x2 to xn to the power 1 by n is also tends to L as n tends to infinity. Okay, these two results used here. Now for the first problem, here we let xn, this is equal to n by n minus 1 for the first problem, and clearly this can be written as 1 by 1 minus 1 by n, and this is tends to 1 as n tends to infinity. So we say that this is L equal to 1, but this is not equal to 0. And using the second rule or consequence of Cauchy's first limit theorem, we find the value of x1, x2 to xn from here. Now to find the value of x1, we put here n equal to 1, so we get x1, this is equal to 1 by 1 minus 1. Okay, and x2, this is equal to 2 by 2 minus 1, that is 2 by 1. x3, this is equal to 3 by 2, and so on. xn, this is equal to n by n minus 1. Okay, and here we get this is undefined. So to overcome this difficulty, we choose x1. Here we write we choose x1, this is equal to 1, because 1 or 2 or finite number of terms if we choose in a sequence, then the behavior of the sequence cannot change. Okay, so we take or we choose x1 equal to 1, and otherwise x2, x3, x4 and xn all are from this value. Now multiplying all of them, we get x1 into x2 to xn. This gives the value, this is 1 into 2 by 1 into 3 by 2 into and so on n by n minus 1, and getting the result as 2 cancel out, 3 cancel out, and similarly we get the result n. Now using the consequence of this theorem, we get this value is n, so we get x1 to xn, x1 x2 to xn whole to the power 1 by n, this is equal to n to the power 1 by n, and this must be tends to as the same limit as L. So this is 1 as n tends to infinity. Okay, so we prove that nth root of n, this is equal to 1 if we take limit n tends to infinity. This is the first answer, and second answer is most easy. Here we already proved n to the power 1 by n, this is tends to 1 as n tends to infinity. Okay, so we take xn, this is equal to n to the power 1 by n. Now x1 plus x2 plus 2xn by n, we take this is equal to yn, and this gives the result as 1 plus 2 root of 2 cube root of 3 and nth root of n by n. Right, and clearly by using the Cauchy's first theorem or first limit theorem, we say that this is tends to 1 as n tends to infinity, because we already proved that n to the power 1 by n, this is tends to 1, right? So we get the second problem or second limit also. This is very easy by using Cauchy's first limit theorem. Also this is easy problem by using Cauchy's first limit theorem consequence. Okay, very important limit of real sequence. Thank you for watching.